So this video we're going to be working with the area of regular polygons, right? Remember that regular polygon is a polygon that has all sides and angles that are congruent, right? So for that we need two information. First of all, the radius. The radius goes from the center of that um, polygon to any of its vertex, right? And the other one is the apothem. So the apothem goes from the center to the side, right? And it's the distance from the center to a side. So that means that this side right here is perpendicular. The apothem is perpendicular to each side, right? And because it's a regular polygon, the radius at the apothem, it doesn't matter to where we throw it, it's exactly the same, right? So the area of a regular polygon is half the product of the apothem and the perimeter, right? So the perimeter, as you know, is the addition of each side, of all the sides. So it's the half of the multiplication of that, right? And as you know, the area, if two polygons are, two figures are congruent, then their areas are equal. Let's see the first one. So I want to find the area of each regular polygon. So it's telling me right there that they are regular polygons. So that means that this is an equilateral triangle, right? So that means that all of its sides are 8, right? So 8 and 8. So my perimeter here in this case is 8 plus 8 plus 8. So that means that is 24. And now my area is half of 24 times 2.3, right? I know that this is the apothem because it goes from the center to, and it's perpendicular to the side, right? So this is 27.6 units square. The next one, I'm gonna have an equilateral triangle. So this is 16. So my area equals 1/2 of 4.6 times 16 times 3. This is 48, and when I multiply everything, I have that this is 110.4 units square. So this next one, as you can see, I only have the measure of the apothem. I only have the measure of the apothem of this hexagon, right? So first of all, so I'm gonna draw this triangle right here so you can see better, right? This triangle right here, right? So once I draw that triangle, right, I can find the measure of this angle right here. Right, that measure is going to be 360 divided by 6. So that means that is 60. So that means that this whole angle is 60, right? But when I have an isosceles triangle, remember that the radius are congruent. My perpendicular bisector, my height is also my angle bisector. So that means that each angle here, this is 30 and 30, right? So by using a special right triangles, I can find this measure. So let's name that one X, right? Remember that this angle is 60 right here. So that means that my longest side leg equals, so x square root of 3 equals my longest leg, right? So my leg, my shortest leg times the square root of 3 is my longest leg. So that means that x equals 5. Right? So that means that this equals 5, and I know that this equals also 5. So that means that my sides are 10. Right? So my area equals 1/2 of 5 square root of 3 times 6 times 5, right? Why times 6? Because this is, or times, now 5 times 10. Why 6 times 10? Because it's my perimeter, right? So 10 plus 10 plus 10 plus 10 plus 10 plus 10, right? So looking at on the calculator, my area is 259.8 units square. So in this one I have the radius, right? So I need to find the measure right here. Let's draw the apothem first. This is the apothem right there. Again, I'm going to divide by 4 in this case. So this one in red. So 360 divided by 4 is 90. So that means that each one of these angles is 45. Each of the angles is 45, right? And as you can remember, in a 45, 45, my legs are congruent. So that means that this is congruent to this, to that, right? And I have that my hypotenuse is 9, right? My hypotenuse is 9, right? So let's name this x, right? So x. And the hypotenuse in a 45, 45, 90 triangle is whatever is the measure of the legs times the square root of 2. So I can simplify that one by dividing by the square root of 2. So x equals 9 square root of 2 divided by 2. Remember that I'm just rationalizing right there. Right? So this is the measure of my apothem, and it's also the measure of half of the side. Right? So if I multiply that times 2, I have that a whole side is 9 square root of 2. Right? So my area equals to 1/2 times 9 square root of 2 times 9 square root of 2 times 4 times 4, right? 9 square root of 2 is the apothem. 9 square root of 2 times 4 is the perimeter. So my area here is 324 units square. Okay, so now I want to find the area of each regular polygon with a given apothem and side, right? So I'm starting with the next second. So that means that my area equals 1/2 of 12.1, that is the apothem, times 6 times 14, right? Remember that this part right here is the perimeter, so it's 6 sides times 14. So this area equals 508.2 feet square. The next one, I have an octagon with apothem 20.8 and side 17.2. So that means that my area equals 1/2 20.8 times 8 times 17.2. Right, so this area equals 1431.04 meters square. I have a decagon, so that means that this n is 10. So area equals 1/2 31 times 10 times 20.1. Okay, so my area here is 115.5 inches square. So my next one says, a soccer ball outer covering is made by stitching together 12 regular pentagons. So we have 12 pentagons, we have 12, and so we got 12. And we have 20 regular hexagons, right? So both polygons have a side length of 3 centimeters. So the pentagon have an apothem of 2.06 to the nearest whole number. What is the total surface area of the soccer ball? Right? So let's start by finding the area of the pentagon because we have everything that we need. We have the apothem, we have the sides. So the area of the pentagons, let's do it in blue. So area of the pentagons, let's call it P right here, equals 1/2 of 2.06 times 5 times 3. So this is 1/2. So that means that each pentagon has an area of 15.45 centimeters square, right? So now I need to find my area of my uh, hexagons, right? So I know that because all this side right here is 3, that means that each small piece right there is 1.5, right? So if I draw the triangle right here, I know that each of this angle is 30, right? So that means that my apothem, remember that I have a 30-60 triangle right there. My apothem is 1.5 square root of 3, right? So 1.5 square root of 3. So the area of the hexagon, is 1/2 of 1.5 square root of 3 times 3 times 6, right? Remember that is 1 is 6, so the perimeter is just 3 times 6. So that means that the area of each hexagon is 23.38 centimeters square, right? So now we want to, first of all, I'm going to round each one, right? So this is 15 centimeters square, and this one is 23 centimeters square, right? Why? Because it's asking me to the nearest whole number. So now my total area, my total surface area, so let's call it SA. SA equals, so again, I have 12 regular pentagons. So that means I have 12 times 15 plus 23 times 20. I have 12 regular pentagons, and I have 20 regular hexagons. So 12 times 15 plus 23 times 20. So my surface area is approximately 640 centimeters square. And that's it for this lesson. May the force be with you.